So yesterday we did A, and then I let you guys do B with the reminder that you do have to make sure that you take the power into account. So if it's 2x cubed, remember it's 2x times 2x times 2x, so that's an 8x cubed. So 8x cubed is the first term. This would be 4x squared. So you have to multiply the 4 by the 3. So this is going to be 12x squared y when you multiply down. Okay, and then 3 times 2 is 6, so this is 6xy squared. And then the last one is y cubed. So this should be your final answer for B. And if you did it right, you'll notice the x's go 3, 2, 1, none. And then the y's start at 0 and then go 1, 2, 3. Okay, so that should always happen with what you have. Alright, so for this one, we're going to use row 4. Okay, and then if I see like I have a negative or a number in front, I do space them a little bit further apart, and that's just so I have room to simplify, but you can find what works for you. So the coefficients in Pascal's triangle in row 4 are 1, 4, 6, 4, 1. And then you start with the first one, and that's going to be x to the 4th, x to the 3rd, x to the 2nd, x to the 1st. And remember, I said for x to the 0, what did I say is fine to just put right away? 1. Okay, and then for this one, you have to make sure to take the negative, but anything to the 0 power, even negative y, so the 0 is 1. So this is going to be negative y to the 1st, negative y to the 2nd, negative y to the 3rd, and then negative y to the 4th. Okay, so when we multiply down, you have x to the 4th here, okay, and then this is like a negative 1 in front, so 4 times the negative 1 is going to be negative 4, so a minus goes in between. So that might have been a little tricky, so make sure you check that part. And then for this one, if you do negative y times negative y, you get y squared. That's a positive, so this is going to be plus. And then we'll have plus 6x squared y squared. Okay, if you do it to the 3rd power, is that going to be positive or negative? Negative. So this is going to be minus 4 xy cubed. And then the last one, is that going to be positive or negative? Positive. So the rule is, and there's a couple different ways you can think about it, but if you have a negative to an odd power, it's going to turn out to be what? A negative to an odd power is what? Negative, and then a negative to an even power is positive. You can also look here, if one of them is negative, see how they alternate signs here? Positive, negative, positive, negative, positive. So that will naturally happen because of the exponents. Okay? Alright, so for part D, we're going to use row 3, okay, which we already used above here. But see how you have these coefficients? If you have coefficients, I like to just give myself space to simplify, so I spread out the numbers. 1, 3, 3, 1. Okay, and then in the first row, I have 2a to the 3rd, 2a to the 2nd, 2a to the 1st, which is 2a, and 2a to the 0, which is 1. Okay, and sometimes I just simplify this right away. So I know 2 cubed is 8, so this is 8a cubed. This would be 4a squared, and then those are the same. Now here, I have to take the negative and the 3. But again, anything to the 0 power is 1. And then this would just be negative 3b to the 1st, negative 3b squared, negative 3b cubed. Okay, so this is an even power, so this should end up being positive. Negative 3b times itself is 9b squared. What's a negative 3 cubed?
9b.
So, but 3 cubed would be,
Oh, 37.
yeah, negative 27, and then b cubed. All right, now we're ready to multiply straight down. Okay, so this is 1 times 8a cubed times 1, so you have 8a cubed. This one, you have 3 things you have to multiply, the numbers. So 3 times 4 is 12. 12 times negative 3. Yes, so this is negative 36 a squared b. Okay, and then for this one, we do 3 times 2, which is 6. Multiply that by 9, that is 54. And then the last one is just the negative 27 b cubed. Okay, so this is another time that alternates. Positive, negative, positive, negative. Alright, so what we used there was the binomial theorem. Okay, and yesterday we skipped over that. So I said we were going to talk about it today. So the day is here. Alright, so let's go to the front page. And we're only going to briefly talk about it. So we're going to go back to the binomial theorem and we're going to talk about what that means for us. Okay, so the binomial theorem, you can use that to do the binomial expansions, which is what we just did. What we didn't talk about yesterday is how they are related to combinations. And that's going to be what we talk about today. So the pattern that's in this table, that can help you expand the binomial when we do probability, which we are going to be doing some probability to help us with statistics. So chapter 8 is all about statistics, but remember, we're just doing 2 sections from that. And then if you want to go further into statistics, you have AP Stats you can take, or there is just a semester elective as well. Okay? Alright, so this is Pascal's triangle. This is showing you how these relate to the combinations. Do you guys remember how you can do the combinations on your graphing calculator, where you find them? Okay, so maybe we need a quick refresher. Okay? So these combinations here are the same thing as Pascal's triangle. So this is like a combination is out of 0 items, you don't choose any. Okay, so it's like how many situations is that? Well, if you don't have anything, you don't choose anything, only one thing that happens. And that's that you choose nothing. But let's go ahead and verify that. So type in the first, 0, and then go to math, arrow over to probability, and then you're going to choose the combination. Okay, so see how there's only one choice? Okay, that matches the number there. Okay, anytime you have, or you're choosing nothing, there's only one choice. Okay, so that one would result in a 1 as well. And when you only have one option and you're choosing that one option, again, there's only one choice, that's why it's 1. Okay, so if you look at these, they actually relate to the rows of Pascal's triangle. What row is this one? Yes, this is row 0. Okay, this is row 1 of Pascal's triangle. This is row 2. This is row 3. Okay, so what we can say is that when you're looking at this, the NCR, Okay? The value of n is the row number. And you're starting with 0. Okay, now for the next one, the entries, R is going to be the entry number. And again, you have to start with 0. So it would be like the 0 entry, then the first entry, then the second. So this would be the entry number. In the row, and again, you have to start with 0. Okay, so the reason why that would be helpful is if you had Pascal's triangle and you were trying to calculate the 3, choose 1, you could just go to the third row, go to the first entry, which isn't really the second entry, right? Because this would be the 0 entry, this one will be the first. And if you do 3, choose 1, what should you get? 3, choose 1 should be what? 3, right? Because they should match. This should match this. This should match this. Okay? Now, can you use your calculator? Yeah. So you don't have to relate the combinations to Pascal's triangle. Okay, but that's why they do talk about Pascal's triangle in this section. Okay, it's because you can relate it when you're trying to find different combinations, which is what we're going to do today. Yeah?
So basically, like, everything, so like for row 3, all like the 3, choose 0, 3, choose 1, 3, choose 2, 3, choose 3, that matches the 1, 3, 3, 1.
Yep. So if you do 3, choose 0, you'll get 1. If you do 3, choose 1, you'll get 3. If you do 3, choose 2, you'll get 3. And then 3, choose 3, you'll get 1. Yeah? And then those are related to your binomial expansion, because if you had something to the 0 power, it would just be 1. If you had something to the first power, that would match the second row, the coefficients. So it would be 1 and 1. The coefficients here would be 1, 2, 1, which matches Pascal's. And then the last one will be 1, 3, 3, 1. Okay? And that happens anytime you don't have the coefficients there. Now, I know the next equation is overwhelming, but I do want to explain to you how this works, what it means, because you might see certain terms on the PSAT, the SAT, and once you know what they mean, it's a little bit easier to apply them, okay? So this is the binomial theorem. This is just the binomial expansion that we did, but bless you, it just looks a little crazy because you have this n choose 0 here, you have this n choose 1, n choose 2, and then that keeps going on until you get to the last numbers, the n choose n. What I want you to look at in this one is, see how this is x to the n power here, and then it goes x to the n minus 1. Okay, what's happening here is this is a way to write a certain term. So let's pick a number. Let's say n was 5. What would n minus 1 be? 4. And then n minus 2 would be 3. Okay? So this is just going to be the term before n. Okay? So if it was 20, it would be 19. So sometimes you might see the n minus 1, and people get confused about seeing n minus 1. That just means it's the number before n, whatever your n value is. Okay? This isn't anything like that you have to have memorized. It's something you already do naturally with what I taught you with the Pascal's triangle. Okay? I just thought that would be helpful for you to know going into some of those standardized tests. So when it says to use the binomial theorem to expand, Okay, we're still just using the row of Pascal's triangle, and then this is the n power. This is n minus 1. This is n minus 2. This is n minus 3. Okay, because your n value for this is 5. Does that part make sense? So they're just going down. So if this is row 3, your n value is 3, n minus 1 is 2, then 1, then 0. Okay? Alright, so what we're going to focus on today is an equation for binomial probability. And it is going to relate some of the stuff that we did in chapter 7. So this is talking about binomial experiments. Do you guys remember some of the different experiments we talked about in chapter 7?
Coin.
Yes, flipping a coin is an experiment. Yes, rolling a die. We also did some stuff with cards, right? Okay, so we're going to have different trials. So they're not going to be just what we did in chapter 7. We're going to expand from there. Now, for whatever you're doing, you have a probability of success. Okay, something that you want to happen. Okay? Do you guys have a favorite side of the coin? Like, do you guys always go with heads or tails? I like tails too, but I feel like, I think a lot of people like heads, right? They always say, this is what it is. So whatever the situation is in the problem, it will tell you what they want the success to be. So if it was, let's say that the success was tails. So what is the probability of getting a tails? 50%. So then that means your success for failure would be what? 50%. Because they both have 50%, and also both percentages should add up to what? 1. Okay? I'm going to show you another one. We can ignore this. Okay. So let's say you're rolling the sides of a number cube. It really doesn't matter how many rolls you have. Let's say our success is rolling a 3. How many sides have a 3 on them? Oh, only one of them does, right? So then our success would be 1 out of 6. Okay? The failure would be that you roll anything besides a 3. How many sides have anything besides a 3 on them? 5. So this would be your probability of failure. Okay? And then again, together, that probability has to add up to what? 1. Because that's 100%. That's the whole. Okay? Alright, so they tell you P is the probability of success. What is the variable for failure? It's P and Q.
Is that like whenever you're trying to solve, like, find, like in a quadratic equation?
No, but we did talk about P's and Q's when we did the P over Q for the rationals. Yeah, they also use that for in that situation, but these two are not related. Okay, so the binomial probability that there will be exactly R successes, and R is going to depend on what the success is in the problem, so that's going to change. Okay, so for exactly R successes, we have this equation. Okay, and we are going to write this out. So this is P of R, so the probability of R equals NCR, so that's the combination, P to the R power, and then Q to the N minus R power. So one of the first things that you're going to end up identifying is the P and Q. So for P, you are going to find the probability of whatever they define the success to be. So that's going to be given to you in the problem. And then the Q is going to be the probability of failure or that not happening. Okay, and this textbook likes free throws, so we're going to talk about free throws in here. What about basketball players? Who's Rashawn? You have a basketball? Okay, so Jean usually makes half of her free throws in basketball practice. What do you guys think? Is that average? You guys make more than half your free throws in practice, right? You have to run suicides if you don't. You guys do that at the end of practice? That's what we used to do. Like you would be a new person each time and get on the line. You hope they make it, so you don't have to run. Do you guys do drills like that in some of your other sports? What we got? Some tennis players in here? Girls tennis? Swimmers? Do you guys do suicides and swimming?
We have like get out swims.
What's that?
So like a coach. So our team we rarely do this, but at my old team we do.
Yeah.
So like say we have like the rest we have what like 30 minutes of practice left, and someone could ask like to do a get out swim, and so the coach would give them a certain time they'd have to be.
Oh, and if they don't.
And the coach would choose their event that they would have to swim and the time they would have to go. And if they don't meet that time, then the rest of the people have to finish the practice.
Oh, okay. But if they do, then it's done?
They get to get out.
Oh, that's awesome. Okay, so Jean's making half of her free throws, and today she is trying how many? 3. Okay, so she is trying 3 free throws. We're going to find, for part A, we're going to find the probability that she will make exactly 1 of her free throws. So the language in here is going to be important, just like it was in chapter 7. So exactly 1, see how this is exactly R? That means we can use that equation, okay? So exactly 1, that means our R value is going to be what? 1. Okay, so exactly R, so this value is going to be R. Okay, does anybody know what our N value is going to be? 3. Good, because that's how many free throws. Okay, so N is the total. Okay, N is going to be the total, the number of trials. Okay, so in order to use our formula, we also need the probability of success and the probability of failure. So what is the likelihood that she will make a free throw? 1/2, because she makes half of her free throws in practice. So you can use 1/2 or you can use the 0.5. I'm going to use the fraction on this one. Later we will use a decimal. On your homework or on a quiz you can choose. I just want to practice some of those mental math skills for your test coming up. So if the success is 1/2, the failure is 1/2. Okay, you find that by doing 1 minus 1/2. Okay. All right. So I'm going to write out the formula because this is our first time doing it. So this is the probability of R equals NCR, P to the R, and then QN minus R. These types of problems are not difficult to compute, it's just the setup. Okay, so if you have the setup right, then usually the rest of the problem goes very well. So our R value is 1, so the probability that she'll make exactly 1 free throw, I'm going to use my N value, which is 3, so this is 3C1. And then your probability of success is P, so that's 1/2, to the value of R, which is 1. And then this is Q to the N minus R, so this is 1/2 to the 3 minus 1. Okay, now the 3C1, you can either use your calculator or you can use Pascal's triangle. So remember I said the first number means the row and this is the entry, okay? And remember with the entries you start at what number though? So it's 3, choose 1. So in this row, what is the number 1 entry?
1.
No. That's the 0 entry. You have to start at 0.
Oh, you start at 3?
So it would be 0, 1, 2, 3 are the names of the terms. Okay, so it would be 3 for this. And again, you can also use your calculator. I don't really like that it's not the first entry, but you do have to start with 0 because there is a probability that she doesn't make any of her free throws, so you do have to take that into account. So you can also do 3, choose 1, okay, and that will give you 3. 1/2 to the first power is just 1/2, and then this is 1/2 to the second power. Now, if this is 1 and this is 2, notice they add up to 3. That's something that we're going to pay attention to. And we are going to square this without a calculator, and then we are going to write our final answer with it. Yeah.
Wait, so on the calculator it says like 0, like C or whatever?
No, you got to put in the 3 first, so like 3 NCR1. And then if you were writing this as a fraction, it would be 3/8. And then we are going to be rounding our answers to the nearest 1/10 of a percent, which means as a decimal, if you need to, if you're doing it to the nearest 1/10 of a percent, how many places after the decimal should you be going?
1.
No? Well, yes, sorry. When you round the percent, yes. When it's a decimal, though, you're going to have to round to the 3, the nearest 1,000. Okay? Because what would this be as a percent? 37.5. So yes, as a percent, 1 place after the decimal. As a decimal, do your 3 places. All right.
Could you explain that, what you were saying again about the 3C1?
Yeah, so I'm saying if you wanted, you could use the Pascal's triangle, but remember, when you use Pascal's triangle, the entry number in the row, you have to start with 0. Okay, so that means every single row, this entry here that comes first in it is really entry 0.
Okay.
So every 0 entry is going to be what?
1.
Yes. And then the first entry would be the second one that you see. So every first entry is going to be the row number.
So you start, okay, for this one you put in first entry.
Yes, which is the second one you see in the row. Because it starts at 0. So it goes 0, 1, 2, 3.
So it's more like a by the way you're saying instead of like what should be.
Yes.
So you can only use Pascal's triangle if it starts with a 0.
No, you can use your calculator for any of those. That's fine too.
Okay.
Okay? Yeah, so you can just do the NCR in your calculator as well. That's perfectly fine. Yeah, I'm just showing you how it relates to the Pascal's triangle and why they're even mentioning that in here. Okay, so now for B, it says, what's the probability that she will make at least 1 free throw? So the language is a little bit different. The first one wasn't at least 1, what was it? Exactly 1, okay? So if it's at least 1, let's think about what that is for this situation. How many free throws could she make if she makes at least 1? 1, 2, or 3, okay? Because she's shooting 3 free throws. Okay, so what we could do to find that is we could find the probability that she makes exactly 1, add that to the probability that she makes exactly 2, and add that to the probability that she makes exactly 3. Okay, so we could find each one. Let me come back. Okay, and then I'm going to have you guys set this up. So we're going to do P of R equals NCR times P to the R times Q to the N minus R. And then we've already found P to the 1, okay? So we did that in the first one. We got 0.375. So I want you to do the probability of finding 2 and the probability of finding 3. So most of your values are going to be the same. The only difference now is when you do NCR, it's going to be 3 choose 2, but your success is still the same. So it's 1/2 to the value of R, and then 1/2 to the value of N minus R. So N minus R is 1. I want you to notice that this value and this value are the same, R and R. These two values add up to what? Yes, these two numbers should add up to the N. Okay, so will you calculate that as a fraction and then as a decimal? And then after you do that, go ahead and find P of 3. Okay, so I'm going to give you a minute to do that. Okay? And feel free to check in with the person next to you once you calculate it to make sure you're on the right track. Yeah. Yeah, looks like it's going pretty well. So when you did 3 choose 2, what did you get? 3 choose 2 is 3. 1/2 squared is 1/4 times 1/2. And then when you multiply your fractions, that's 3 over 8. So we just did that, right? So we know that 3 over 8 is what is a decimal? Yeah, 0.375. So the same thing we got the same thing that we got there. Okay, so the probability that she gets exactly 1 free throw is the same probability that she gets exactly 2. And if you think about it in terms of Haskell's triangle, in row 3, remember, you have the 2 3s back to back, right? Okay, so, and because it's half and half, because these are the same, okay, your final probability is the same. That doesn't always happen, it's just because these two numbers are the same. All right, and then when you did 3 choose 3, you would have done 1/2 to the 3rd and then times 1/2 to the 0. But anything to the 0 power is what? 1. And when you do 3 choose 3, you should get 1. Okay, so this is 1 times 1 over 8. 1 cubed is 1, 2 cubed is 8, times 1. And then what's 1/8 as a decimal?
0.12.
Good. So then your last step is just going to be to add them together, and then we're going to write out our percent. So 0.375 plus 0.375 plus 0.125. Okay, and this was an exact value of 0.875, which means there's an 87.5% chance that she makes at least 1. All right, so moving on. on to example 3, we have a new situation. So A and B were about Jean's free throws. Okay, and example 3, we're talking about students who are assigned to guidance counselors. Okay, and they are randomly assigned to one of 3 guidance counselors. What we have to find out is what is the probability that Counselor Jenkins will get 2 of the next 3 students assigned. I should have put Ms. Crunchfile and Mr. Laffer in there. More relevant. Okay, so again, let's just start by identifying what our R value is, what our N value is. And let's make sure that we're paying attention to the language. This one doesn't say exactly or at least, so do you guys know which one it is? There is one of them that's implied. So what's the probability that this counselor will get 2 of the next 3? Does that mean at least 2 or exactly 2? Exactly 2, okay? So that means our R value is 2. Okay, so I'm going to get 2, that's our R value. And then the N value is the total, so how many total students are being assigned? 3. So that's going to be our N value. Okay, now the probability of success is given to you in the problem, but sometimes it's written out in words. So the probability that they get a student is what? No, but you're close. Yeah. So students are assigned randomly to 1 out of 3. So they have a 1 out of 3 chance of getting Jenkins, right? So if it was Brunschweiler, Lepper, the new Jenkins that we hired, okay, you'd have a 1 out of 3 chance of getting them, okay? So the success is 1/3, which means the probability of failure has to be what? 2/3. Okay, these 2 together will always make what number? 1. They will always be 1. Okay. All right. So now we're going to use our formula. So the probability of 2, exactly 2. Okay, we're going to do the NCR. So again, I wrote mine right here so I can look at it. So my N value is 3. And then out of 3, there's going to be 2 of them that we're seeing. They get 2 of the next 3 times the probability of success, so 1/3. And remember, these 2 always match to the second. Now this one is 2/3, so the failure, 2/3. Okay, to the first, because 3 minus 2 is 1. And then as you practice that, you will get good at just being like, oh yeah, 3 minus 2, 1. All right, so 3 choose 2. There's that row 3 again. So if it's in row 3, what are the only 2 options for your numbers? 3 and 1. Okay, the ones that are 1 are going to be 3 choose 0, because that's the first entry that you see, and then the last one will be 3 choose 3. So this number has to be what? 3. Again, you can absolutely use your calculator to find that. That's not a problem. Okay, and then 1 squared is 1, 3 squared is 9. Times 2/3. Okay, and if I had to do this without a calculator, I would start thinking about things that cancel, because aren't 3 and 3 going to cancel here? Yeah. So then this would be 2/9. And then remember, when we're rounding this, I said you're rounding to the nearest 1/10 of a percent. That's 3 places after the decimal. So 2 divided by 9 is 0.2 repeating. So we're just going to leave it as 0.222. Really, when you're changing it to a percent, how are you guys thinking of that? Are you just thinking of moving the decimal? Yeah, you move the decimal 2 places, and that's because you're multiplying it by 100, because all percents are out of 100. Okay, so there's a 22.2% chance that they'll get 2 of the next 3 students assigned. Right, now we're going to talk about multiple choice. Okay, and kind of wish I would have worded these questions different, because I know when you guys have multiple choice tests, you guys think about, what if I just guessed? Could I get 100%? What's the probability of me getting 100% if I just guessed on all of them, right? So I should have done that one, but we are going to be doing similar things. So Ellen's taking a multiple choice quiz. It has 5 questions, and it has 4 answer choices for each question. So there are 5 questions, 4 answer choices for each question, and we have to find the probability that she will get at least 2 answers correct by guessing. Okay, so with your row, I'm going to have you fill in a few things, but this one is a little different. It's at least 2. So if it's at least 2, okay, what does that mean? Yeah, it's not exactly 2. So there's not just one R value. We're going to have to find several. So at least 2 means she could get 2 right, or 3, or 4, or 5, right? Okay? So with your row, I want you guys to identify what N is, the probability of success, and the probability of failure. Okay? So at least talk about it, even if you're not 100% sure and you don't want to write it down yet. Think about what your probability is. So remember, N means the what? Total. So how many total questions are there? 5. So N is going to be 5. Now the success, you guys already know this, okay? Because I've heard people be like, oh, they're taking a multiple choice test. I have what chance of getting it right? If there's 4 answers, I have what percent? 1/4 or 25%. Okay? And really, you can use either the 1/4 or the 0.25, doesn't matter. So that means my probability of getting it wrong is what? 3 out of 4. Yep. Great. Okay, now, yes, go ahead. Because there's only 4 choices. So there's only A, B, C, D. So, there'll only be 1 correct answer, and then the rest will be wrong. So 1 out of the 4 are correct, 3 out of the 4 are wrong. But you have that for every one of the 5 questions. Yes.
So it's like a 1/4 chance for like all 5 of the questions. So
Yes.
It's like 5 questions, there's a factor to it, making it like 5 out of 1.
So we are gonna go over that part, because you're thinking of it like in chapter 7, and now I realize I answered 2 questions somebody else asked me earlier that I wasn't getting, but now I'm on the same page. Okay, so for this one, there's 2 ways that you can do this. we can find the probability of 2, 3, 4, and 5 and add them together. That would be method 1, okay? You could find each one, but that means I have to do 4 different equations. Okay, and then, Lizzie, what's another way we could do this?
Take the ones that it could be, so you get 1 minus 1.
Yeah, so remember how in chapter 7 we use the complement? Because remember we're trying to find the probability of that everybody chooses the same versus the probability that everybody chooses something different. But it was a lot easier to do 1 minus that value. What's the probability that she doesn't get at least 2 answers correct? What would that mean? How many would she get correct? If she didn't get at least 2, she could get 1 right or 0, okay? So we could find the probability that she gets no questions right and the probability that she gets 1 question right, and we could just subtract that from 1, couldn't we? And you could choose which way. I believe this way is faster because look, you only have to find these 2, okay? You only have to find P of 0 and P of 1 and then just subtract it. So I'm going to use method 2. You can choose whichever one you want to, okay? Alright, so I'm going to do method 2, which means I have to find P of 0 and I have to find P of 1. Those are the 2 things I'm going to find. Okay, so I have 5, choose 0, and then 1/4 goes to the 0, 3/4 goes to the 5th. Okay, so remember, anything that ends, if it's 0, that 0 entry is always 1. Again, you can plug that into your calculator. 1/4 to the 0 is 1. So this is just 1 times 1 times 3 to the 5th is 243. 4 to the 5th is 1024. Okay, and then we're just going to find this as a decimal. So we're just going to do 243 divided by 1024. Okay, so we get 0.237. Okay, and then for this one, it's going to be 5, choose 1. 1/4 would be to the 1st power. 3/4 would be to the 4th power. Okay, and again, we're just going to calculate that. So you can calculate this in your calculator using that probability, or you can use Pascal's triangle. And 3 to the 4th is 81. 4 to the 4th is 256. Okay, and something like this you can absolutely use your calculator on. You can do all of those together. So like if I were doing that in my calculator, I could do 5 times, I would just change that to 0.25 times, and then in parentheses, 81 divided by 256. And then remember, you're doing 3 places after the decimal, and we're rounding that one. Okay, and then I put this in parentheses so you remember to subtract each one. You can either add them together and then subtract from 1, or it's fine if you're in your calculator, you just do 1 minus 0.237 minus 0.396, and that will give you 0.367. And this is rounded, so it's approximately 36.7%. example 5 is just like that. I'm going to have you start on that. So the direct way to solve the problem is method 1 that we talked about above. And then the faster way is to use, do you guys remember what I said that was called? Yes, good, the complement.